colleagues Huna. Today we're gonna learn about Pearson's R. We're gonna focus on how it is used in research. So what is Pearson's R? The Pearson correlation coefficient, often denoted as R, is a statistical measure that assesses the strength and direction of a linear relationship between two quantitative variables. In other words, Pearson R is used to understand how different variables relate to each other. It is widely used in research, often referred as the bivariate correlation or the Pearson product moment correlation coefficient or the PPMCC. Carl Pearson is recognized for formalizing and popularizing the correlation coefficient known as Pearson R. Researchers use Pearson's R to test hypotheses, determine if a relationship exists between two variables. It is also used to predict outcomes, to estimate the value of one variable based on the value of another, and lastly, to understand relationships, gain insights into the nature and strength of associations between variables. This is an example of a research study that uses Pearson's R. The research study investigates the relationship between the height, weight, BMI, and speed performance in the university female students of South Telangana. Their study aims to determine the relationship between the following variables among university female students: the height and speed performance, the weight and speed performance, and the BMI and speed performance. So this is the formula used for calculating the Pearson's R, where R is the correlation coefficient, the x values of the x variable in a sample, the x bar is the mean of the values of the x variable, the y is the values of the y variable in a sample, the y bar is the means of the values of the y variable. This is the interpretation of R value, where the positive one indicates a perfect positive correlation. As one variable increases, the other increases proportionally. However, the 0 indicates no linear correlation, meaning there's no clear relationship between the variables. And the negative 1 indicates a perfect negative correlation. As one variable increases, the other decreases. So this is an example of a table only. This is not the actual data. This is only an example to help you understand how to get the Pearson's R. So first, we need to get the total of the x and y variables and find their mean. As you can see, the mean of the height or x is equals to 162.43, while the mean of speed is 6.47. Next, we need to find the difference between the x and the mean. For example, 160 minus the mean, which is 162, is equals to negative 2.43. Same goes for the next column. Next is to multiply the difference of x minus x bar or the mean and y minus y bar or the mean of the y variable. For example, 2.57 times 0.33 is equals to 0.85. Another example, 7.57 times 0.63 is equals to 4.77. For the next column, we need to square the values of the table of this table and this this column and this column. For example, the squared value of negative 0.27 is equals to 0.07. This is how to solve for the R value. Use the formula, substitute the values, and find the R value. Same goes to the weight and speed performance. Their R value is 0.89. For the BMI and speed, their R value is negative 0.20. So what to do after you find the R values? First, we need to find the t value using a formula, which the t value of 0.76 is 2.54. This is the formula to calculate the t value. Next, we find the degrees of freedom, which is by subtracting the sample size, which is 7 to 2, which results to 5. This is the solution. Next, choose your significance level. You can decide what significance level you'll use. And today, for the example, I'm gonna use the 0.05. After you find your significance level, you find the critical value, which is obtained from a t-distribution table or a statistical software. It is based on the degrees of freedom and the significance level. For our previous example, the degrees of freedom of 0.76 is equal to 5, and our significance level, which is 0.05, the critical value is approximately 2.571. After you find the critical value, you compare your calculated t-value to the critical value. If the absolute value of the calculated t-value is greater than the critical value, then you reject the null hypothesis. This means there is enough evidence to conclude a statistical significant correlation. For example, the R value of the height and speed performance is 0.76. The calculated t-value is 2.54, which is less than the critical value 2.571. Therefore, we fail to reject the null hypothesis. There is not enough evidence to conclude a statistically significant correlation at the significance level of 0.05. The same goes for the R value of BMI, which is negative 0.20. We also fail to reject the null hypothesis. Next, if the absolute value of the calculated t-value is less than or equal to the critical value, then you fail to reject the null hypothesis. For example, the R value of weight and speed performance is 0.89. The calculated t-value is 4.77, which is greater than the critical value 2.571. Therefore, we reject the null hypothesis because there is enough evidence to conclude a statistically significant positive correlation. Based on the results of the findings, it was concluded that there was a significant relationship between the weight and speed performance. However, there was no significant relationship between the height and speed performance and the BMI and speed performance. Thank you for listening, and I hope you learned something in my video. Thank you.